Okay. Welcome back. If anyone's here yet. Should we have the sound on somewhere? There we go. Yeah, so welcome back to another day of AoC, Advent of Code. Yesterday I only managed to do part 1 on stream. I came back later in the evening and did part 2, but I cheated. I looked at someone else's solution, Nari Moran's on IRC and on GitHub. Sorry. So this is my solution for that from yesterday. You might remember I was just bumbling around with like timing everything by 2 and nothing really working, and I started looking at sequences of stuff and trying to figure out if there was some pattern, some rule there we could use. None of it really worked. I looked at Naramiran's solution, and it took me a while to see what was going on here, but it's really quite clever. So what he does, so I've renamed the variables and written it in sort of my own style. But basically what we do here is that we set up a count table, which stores the ways in which we can reach a certain adapter, like the value of the adapter. So we simply start by saying that 0, we can reach 0, so the starting voltage or joltage, in exactly one way. There's one way we can reach that. Just add the final one. Actually, I don't think we need this. I want to check that actually. As you can see, it runs super quick. I don't think we should need this. No. Because there's only, since it's 3 higher than our highest adapter, there's no way that we can get, like there's only one way to get to the highest adapter, and that is through the second highest, which is 3 lower than the highest by definition. So for adapter and adapters, so just go through all the adapters, and now we're doing the joltage of the adapter. So the joltage of, or the number of ways we can reach this joltage is the number of ways we can reach all of the adapters smaller than us, or that are sort of in reach. So basically, if we look at this thing, so you know that 0 has a count of 1 to begin with. So the number 1, so 1 minus 1 here, 1 minus 1 is 0. So this is going to be 1, and this is going to be 0, and this is going to be 0. So there's only one way we can get to the number 1. Which makes sense. You can come from 0, you can go to 1. Same for 4. 4 minus 1 is 3. 3 doesn't have any. 2 doesn't have any. Minus 3 is 1, and 1 has one way. We can reach 1 in one way. So that gives 4 a value of 1. Same again for 5. The only number, so 5 minus 1 is 4. Both of these are 0, so there's one way to reach 5. But 6, you can reach 6 either through 5, so that's 1, or through 4, so that's another way we can reach 6. So now 6 has 2 ways we can reach it. We can either come 1, 4, 5, 6, or we can go 1, 4, 6. That's 2 distinct ways in which you can reach the 6. Onto the 7. The 7 now can start with one of the 2 ways of getting to the 5. So it's two possible ways if it's coming from the 6. If it's coming from the 5, it has another way, because there's one way to get to the 5. And if it's coming from the 4, there's one way to get to the 4. So it has a total number of 2, 3, 4 ways of getting to the 7. We can actually have a look at these numbers. If we do this and just echo out all the adapters. Not the adapter, sorry. Ways to reach. So yeah, this is the short example that had 8 different ways of doing it. Yeah, my unmodified version. I was modifying this to see, because as you might remember, my solution also worked for this one. So yeah, as I was saying, 7 has 4 ways of getting to it. It's the 2 ways to get to the 6, and it's the 1 way to get to the 5, and the 1 way to get to the 4. 10, only 1 way to get to 10, and that's through 7. But since there's 4 ways of getting to 7, there's also 4 ways of getting to 10. 11 can only be reached from 10, so it also has 4 ways of getting to 11, because it has the 4 ways of getting to 10, and all of those have 1 way of going on to 11. And again, now 12 is 11 plus 10, because we can either get directly from there or via the 11. So 12 should be 8, yep. And so on and so forth. So these are all so far apart that they just carry on. But yeah, anyways, that was part 2 of day 10. So let's have a look now at day 11. As you can see, I haven't started it yet. Haven't looked at it. I did. Vindar posted some over on IRC, posted some fancy graphics of some kind. So I have seen it's something to do with, or he was using some kind of like evolutionary thing. Looked kind of cool. So I'm curious about this one. Seating system. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you're so early nobody else has arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. So we're in the waiting area, and our puzzle input is the seat layout. Okay. The seat layout fits neatly on a grid. Each position is either floor, which is a dot, an empty seat, L, or an occupied seat, pound. For example, the initial seat layout might look like this. Since we were the first one here, there's no occupied seats. There's just empty seats and floor. And it's a really weird seating layout. Looked like they just threw a bunch of chairs in a room. Now, you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. If only it was that easy in real life. All decisions are based on the number of occupied seats adjacent to a given seat. So kind of, I guess, like Conway's Game of Life. For anyone who's programmed that before. One of the 8 positions immediately up, down, left, right, or diagonal from the seat. Right, so sort of the 9 a 3 by 3 square without the center bit. The following rules are applied to every seed simultaneously. If a seed is empty, L, and there are no occupied seats adjacent to it, the seed becomes occupied. So for every L that there are no seats around, it becomes occupied. Or I'm guessing, no occupied seats, so I'm guessing floor is fine. If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat state does not change. Floor never changes. Seats don't move, and nobody sits on the floor. Again, if only it was that easy in real life. After one round of these rules, every seat in the example layout becomes occupied. Obviously, because these are applied at the same time. So we look at this. This is empty. We're gonna. There are no one around because no one has sat down yet, so it's gonna be filled, and that holds true for every seat because all of the rules happen at the same time. So we fill up all the seats. After a second round, the seats with 4 or more occupied adjacent seats become empty again. So these are the seats that had 4 or more, or the L's here are the ones that had 4 or more adjacent seats. This process continues for 3 more loops. Tick, tick, tick. At this point, something interesting happens. The chaos stabilizes, and further applications of these rules cause no seats to change state. Once people stop moving around, you count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until no seats change state. How many seats ends up occupied? Okay, so simple, quite a lot of seats, but a fairly simple, I'm thinking fairly simple iterative algorithm. Do the same kind of double buffering that you do in Conway's Game of Life. Keep one buffer for the state now, fill up another one with the state to come, and then swap those around. Of course, we don't really care about memory characteristics and stuff like that, so we might just do it a bit easier. Again, our usual inputs. Seating, let's do our normal 2-sack of lines of the inputs. But then we're gonna... Actually, we can use this directly. We don't have to, we don't really have to parse this into something more efficient. We can just keep it like this. So we're gonna do seating, and we're gonna do, I guess just new seating is equal to seating. And changes. So let's set this to something other than 0. You know what? Yeah, let's just set it to -1 for now. No. This is where I wish Nim had a do while, because basically we want to do while changes is not 0, and then we want to count changes for every time we change the seed to something else. But we can't do this because this will never run, right? So let's just set this to 1. Changes equals 0. So right. So 4. So we can index strings in the same way that we index arrays. So we need to loop through sort of this way and this way. So for I in yeah, sure, seeding the length for, or let's just do for x. I know this would be y, because that would be this axis, because it's the lines in our file. And then for x in seeding 0.length, and this should of course be 0.0.0. So this is just the first, for the length of the first of the strings, which is always like, as we can see from our input. Come on, day 11. There we go. As we can see, like all the lines are the same length, so we don't have to worry about that. Now, we need to check. So we need to check the 3. Yeah, I know. I mean, these recordings aren't helping. I record my streams as well. And the worst part is I just deleted some stuff the other day. I should really get a bigger hard drive. It's actually not the one mounted on home. Yeah, it's only like 110, so it's probably like 128 gig drive. Not great. Anyways, so now we have an x and a y for the seat that we're currently checking. We wanna, so if whoops, seating y x, oh that's awkward, okay, it's not the floor, which is basically all we care about, or rather we could do case here actually. So off, so if it's floor, then just carry on this loop. If it's yeah, sure. Okay, so if it's an unoccupied seat, then we need to check the, like, to the left of us and to the right and up and down, and yeah. So for I, or for just call it YY in y minus 1 dot dot y plus 1, oops, plus 1, yeah, inclusive, yeah, sure. And thanks, Juan Carlo, for hosting me. So yeah, so that should like loop through. If yy isn't equal y and wait, if yy equals y and xx equals x, just continue. We don't count ourselves, but we want to count sort of above and to the right and left of us. We also need to make sure that if yy is smaller than 0 or yy is greater than seating that high, yeah, if it's greater than seating that high, then we should continue, and the same of course for xx, but this should be seating 0. Okay, so now we, of course, we need to store neighbors, and if seating y x is equal to So we want to check if it's equal. If it's an empty seat, we need to check if it's what? If it's another empty seat? No occupied seats adjacent to it. Yeah. If seating, so if it's a person, then has neighbor is true. Well, you know what? Let's do this. Let's do some more block magic. Neighbor check. There we go. And so if we have a neighbor, we have already broken the no occupied seats adjacent. So here we can just break our neighbor check. And the last thing we want to do in our neighbor check block is to say, okay, I'm going to finish this, but then I'm going to rewrite it because this is not good for different reasons. So if we get down here, then we should just continue. So we should just like do the next loop. So if we get here, because that means we, oh no, wait, this is where we want to do something. So here we want to say new seating y x is equal to, to an occupied seat. So if we have a neighbor, break out of the neighbor check. If we get here, we know that we haven't broken out of the neighbor check, count the seat as filled in the new seating pattern, so that we don't check this in a later loop. The problem now comes in here because we want to do pretty much the same looping here, right? So what we're going to do here, we're going to write a template for a neighbor loop. Just return an untyped. We're going to grab all of this and we're going to say neighbor loop. I'm going to drop that in here. I'm going to do this. We are going to say we are just going to do grab this one there. Oops, there. Neighbor. And in here, let neighbor equal this thing, but we want to inject this variable, and then we want to run body here, and we take body in as an untyped parameter. So basically what this is doing, again, for people not all that familiar with NIM, this is an AST replacement. So this takes in code that has been parsed by the NIM compiler. It's valid, it's syntactically valid NIM code. Not necessarily semantically valid, but syntactically valid. And we can use body here as a parameter in our code, and it will just be the syntax tree that was passed in here, right? So we do all of this stuff. We sort of require y and x to exist, and they do in this case, and they're gonna do it for the next one, but we can't use this just about anywhere. We also of course require seating. Then we create this neighbor. Oops. We create this neighbor that we inject. So inject here, these are typically, they are so-called hygienic, which means that in here we won't be able to access like yy and xx. But since we inject this neighbor, we are allowed to use this neighbor variable or assignment inside of here, right? Oh, sorry, inside of here. So in this neighbor loop, we can use this neighbor declared here. And in fact, if we do this and just grab, so I'm now grabbing the definition for the symbol I was on, which was the neighbor. Of course, LSP decided to not work with me there, but it should have worked. So yeah, what we can do now here, we want to count we want to count occupied seats. So let's just count neighbors. And we want to say, we want to run another neighbor loop. So as you can see now, we don't have to repeat all this logic with like all of this error checking and all of that. We can just leave that up there. And we can implement our logic down here. So if our neighbor is equal to an occupied seat, then we want to just increase our number of neighbors. And after this, if neighbors is greater or equal than, was it 4? 4 or more. So if you have 4 or more neighbors, then new seating yx is equal to L, because we unoccupy the seat. We are of course gonna have to increase the number of changes in both of these. Case. So cases have to have all branches covered. We're now grabbing characters from a string. So technically, we need to cover all strings, or all 256 characters of ASCII. But we know that we can only get .l and pound, because that's our input. So we just discard all the other ones. And of course, we need down here, after all of this is done, we need to say that seating is new seating. Yeah. That should work. Oop. Isn't that seating YYXX in the template? You are absolutely correct. Good catch. That would have tripped me up. So let us try. So this is the one that will run for 37 occupied seats. Let's just do this. And we want to put this in here. So you want to say that seating is equal to no, we just do this 1, 2, 3, bam, 1, 2, 3 dot split lines, and we're actually not doing any like mapping or converting of that. And we want to count the number of seats. So for line and seating, so seating is set to new seating at the end of this loop. So for line and seating, for seat in line, if seat is an occupied seat, occupied, just increase occupied, 0, this is of course a variable, and echo out the number of occupied seats. Oh, we have an index defect here. Seems to be on line 31. Oh, this of course should be high because nim's looping is inclusive. And that was 37. That's what we expected. Good. So yeah, the dot operator in nim is inclusive. So going to length would bring us to length. And since sequences are 0 indexed, we would then be trying to access one element more. But nim also has this practical dot high operator, which is the highest index in a sequence, which is quite practical. Because, curiously, in nim, for example, arrays, you can do stuff like var x is an array going from 10 to 20 of int. So echo x dot low, echo x dot length, echo x dot high. If you now look at this, our lowest index is 10. There are 11 elements in the sequence, but the highest index is 20. So we can't just simply say for x or for, we can't do for I in x or for I in 0 dot x dot length minus 1 because that wouldn't, those wouldn't be the indexes. Actually, what we should be doing is xx low to high. What would be nice was even to have like x dot indices or something like that. That would be a cool feature. Like have this as an iterator just over this. Save us some typing when doing the proper thing, like doing the thing we should be doing instead of this, because I'm starting at 0, which if I change seeding to be an array that doesn't start with 0, then that would break. Anyways, yeah, so we remove this. Let's run this on my actual input, and that should hopefully complete our day 1 or part 1 of day 11. There we go, 1 star closer to saving your vacation. Part 2. And this was where I messed up yesterday, so hopefully this is going to be a bit, or going to go a bit better. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats, they care about the first seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. For example, the empty seat below would see 8 occupied seats. So this empty seat would see 8 occupied seats because it can see this one, it can see this one, it can diagonally see this one, it can see this one, it can diagonally see this one, and this one, and this one, and this one. Yeah. The leftmost empty seat below would only see 1 empty seat, but it cannot see any of the occupied seats. Yeah. So this one only sees this one, it can't see these ones. The empty seat below would see no occupied seats because all of the cardinal directions, so left, or all of these directions, left, right, up, and all of the diagonals are unoccupied. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more from the previous rules. The other rules still apply: empty seats, blah blah blah, seat matching row rule don't change, and floor never changes. Given the same starting layout as above, these new rules can cause the seating area to shift around as follows. So again, everyone fills up because they can all just see empty seats. And then it goes blah, blah, blah. Again, at this point, people stop shifting around and the seating area reaches equilibrium. Once this occurs, you count 26 occupied seats. Okay. So now let's jump in here. We're gonna re-enable this. Oh, wait. Actually, before we do any of this, we are gonna copy part 1 over to part 2. Nope. And we want to open part 2, and we need to refresh. Come on. Day 11, part 2. There we go. So here we want to grab this. And just do that. Put that there. So now we just have the simple set here. We know that we need to change this rule to 5 or more, like that. And now what's interesting, which is convenient for us, is that we wrote this neighbor loop template. So the only thing we actually need to change now is this neighbor loop template. We could have also written this as an iterator, which I actually think would be cleaner. So I think I'm gonna actually rewrite it like that. So for neighbor and neighbors, we don't have anything called neighbors, right? No. For neighbor, here we do though. Neighbors. Actually, let's call this just scene seats or something. It's seats that we can see. I mean, this isn't necessary in any way. I just kind of want to do it to sort of show off different ways of doing this in them. We take here scene seats. So one thing here is now we of course need to take in seating. So we take in seating as a sequence of a sequence of strings actually. Sorry. And we return a character. You see, we say that we return a character, but this is an iterator. And what iterators in Nim do, oh yeah, adlib on case. I'm not doing that here. How did you figure that one out? But yeah, you can. You can use else and adlib both on case. So yeah, iterator. Basically what they're doing, so this is a normal iterator, not a closure iterator. They're kind of different in them. This iterator is going to be done on compile time. So basically, we are not going to do this anymore. We're not going to do this. We are simply going to yield this thing, right? So what happens here is that the Nim compiler rewrites this for loop so that neighbor, so it puts this sort of here and it sets neighbor to whatever we yield it as. So it's doing pretty much the exact same thing as before, but this is just like a language construct. And as you can see here, we can name the variable. We don't have this like hidden neighbor variable. Like, where did this come from? Oh, it's just defined in this. Of course, with templates, you can do much more than just implement iterators. But yeah, this is sort of the better way of doing this kind of stuff. Anyways, and we can have multiple yield statements, and like different branches and everything. So we're not limited to any kind of structure here. We don't even have to do loops here. We could just have an iterator and just have 100 yield statements for completely different variables or values, and it would just like step through them one by one, and run this for every instance of yield. But yeah, so this part two, oops. Right, yes. Now we also need to take in x and y, which are both integers. Scene seeds for position x and y, scene seeds for position x and y, and of course we are going to need to do like pass seeding as well. So a bit more typing in this case, but it's sort of a more general solution. It's a bit prettier in a way. So this isn't the solution to part 2 yet, and it does not return the right value. So we know we messed it up somehow. X and Y. Why is this not correct? What? We break here. It should break us out of there. What? Neighbors. If neighbor is this, then increase neighbors. Oh, right. Of course, we changed this to be 5 instead of 4. There we go. I was very confused there for a second as to why that didn't work. Yeah, so we updated this to 5 because we got a change of rules. Here saying, where was that? Yeah, 5. It now takes 5 or more visible occupied seats. Yeah, so now we just need to implement this logic here in our iterator. So instead of this, we need the logic for that. Let's just do this. And so we want to check going left, we want to check going right, we want to check going up, we want to check going down, and we want to check the diagonals. So we can do this a couple of different ways. So we have a couple of end conditions for when we want to stop going in a direction. Either we hit a seat, empty or occupied, or we hit the border, like the end of the seating arrangement. So what we can do is for XX in count down from X to 0. So that will go from whatever X is down to 0. And actually we want to do X minus 1 because we don't want to check ourselves. So we just go 1 to the left. So this would be searching leftwards. So if actually let's just do case of seating y XX. If this is a floor tile, we just continue with our looping. If it's an empty seat, we break out of the loop because now we've seen something, but we don't want to yield this because this is not a or wait, actually we do kind of do want to yield it because we're checking for neighbor here. Yeah, sure. Okay. So if it's that, or if it's this, otherwise just sure, continue or discard or whatever. Then we want to yield seating y xx, right? Now we're going to be copying this and running it in the positive direction. So just for consistency, let's use count up. And we want to count up to seeding y dot high. So the largest position, largest value in a line. Still the same loop, still the same thing here. So you see now we've copied this. So we can actually write that as a template. Let's do check seat. Actually, we can just write this as normal procedure. No, we can't because we want to yield inside of it. Seat is just untyped, and this returns untyped. Do this and this. So do a case of seat. If it finds something, yield the seat. So now we can do this and check the seat. We can do the same thing down here. Then we have a nice, we don't repeat ourselves there. I mean, there's still some repetition in this, but it's not too bad. Actually, let's do this manually so we don't mess it up. So now we're gonna go upwards. So that's gonna be X, this is gonna be YY. And downwards. So counting from our X position plus a little bit to the high, so the number of lines. We're going to go YY and X. So now we're checking left, right. Wait, is that left and right for you guys? No. Left, right. I should really mirror this camera. Left, right, up, and down. In these 4 checks here. Now we want to go in the diagonals. Oops, daisy. So we want to go, yeah, it's inverted or it's mirrored. We want to go up and to the left. So we want to go to either, oh yikes. Sure. For offset and count up from 1. So basically what I'm planning on doing is this seating y minus offset x minus offset. So this will bring us diagonally upwards. So this should count up from 1. Let's just not do count up anymore. Go from 1 until the highest of x and y. So if our x is 2, Oh yeah, so Juan Carlo, for you, up and down. Sorry about that. Um, yeah, so the maximum of y and x. So for a 2, that would be 2. We should only check 1. So let's do this. So this is actually a different operator in M. Dot dot less than, which goes to non-inclusive. So that should work. Whoops. And now we need to go. So now we're still going up, but we're going to the right. And that should be to seeding dot seeding 0 dot high minus x. So if we're at the highest index minus 1, that will give us 1. If it's at the top one, the y is 0. Oh, these should be min, not max. If we're at 2, y2, x, all but 1, then that returns 1. Y returns 2. We want to go from 1 to 1. Yeah. Wait. I'm just trying to get these loops right. Whoops. Don't tell anyone about this. It's a secret. Can you hear me whisper? I haven't really checked. I did a lot of like sound tuning with Zoom, like the guy on IRC, not the program. I'm not entirely sure if you can hear when I whisper. Oh, you can. Great. So yeah, let's just check. What does this give us? Just echo out. Fuck. Nothing. Okay. That is not what we want. So we want to do this in this case. So if y is 0, then we shouldn't go anywhere. If y is 1, then we should do this once. That makes sense. Okay, so now we have diagonally up for you guys, diagonally up left, diagonally up right. Now we want to do the same ones, but going down. Actually, let's do one at a time here. So for offset in 1, we want to do, so let's do down and to the right for you guys first. So for that, we want to go to this for seeding dot high minus y and seeding 0 dot high minus x. And now we want to go down and to the left for you guys. Nim ASMR, yeah. Me just softly whispering code lines into your ear. Wouldn't that be soothing? X minus offset. This is of course going to be x. That might have to be a smaller than scenario. Wait, should this be smaller than? If we're at the 0th line, then this is 0. If we're at the first line, we want to do this once. So no, that shouldn't be. I think this should work. Okay, we seem to have some kind of infinite loop there. Here, count down from y minus 1. Oh, you know what? Doesn't this have a smaller than check? Oh. Are there just a lot of iterations to this? Yes, there might be. That's a bit weird that we stopped at the same time. At the same place both times. It's spinning up. I mean, I would think we have an infinite loop here. We shouldn't. There are... I mean, Vindar's was... The animation was pretty long, but it wasn't as long as this. And calculating this shouldn't be this slow. Are we still in the same loop? Oh, you're compiled in release mode, so you can't really tell. Let's see. No, okay. So we're in different loops. Right. Let me see. Okay, so it's definitely not an infinite loop. Because it comes out of this iterator at some point. Why did this completely freeze there? And this is even on the small data set, which is concerning. So if it's a dot, we continue. If it's an L or one of this, we yield the seat. Just do a little sanity checking here. Check that we actually get something. Seem to always be getting occupied seats. Which obviously isn't great. Wait. We start with so we set a seat to this. We increase our changes. Okay, let's just run this for like 3 loops or something. So let's just set up a simple like loop count, and just do inc loop count. If loop count is 3, then break. Otherwise, let's just print out this, and let's print out our seating arrangement. So we print out our seating arrangement after each tick, and we just do that 3 times. And we want to output this in a bit more readable format. So for line and seating, echo out the line. Right. So it all fills up, and then they all empty out. So that's not what's supposed to happen. If you look at this, they should all fill up, and then these corner seats should be occupied still, because they only see like one neighbor here and one neighbor there, and so this one has what, 3 neighbors, and it requires 5 or more to get deleted. So there's something wrong with our logic there. So let's just, okay, so for this tick, the seat is occupied. So let's just say if x is 0 and y is 0, then we want to echo out our neighbor. Yeah. Right. So it sees a lot of neighbors it's not supposed to see. So that I checked, like, we're only outputting for this one now, and it sees all of these neighbors, which is obviously wrong. So our iterator here is doing something strange, which isn't too odd. Let's I mean, we could make some simpler cases here, because we can call this on anything. So let us occupy, or we don't have to occupy that seat. Let us occupy this seat, and then loop through 4 seats in seating.scene seats, echo seat. At 0, 0. So now this should give us the seats seen from this, which should be this seat, and this seat. So we should have 2 L's and a pound. And I'm guessing we're not gonna get that. Nestable statement requires indentation, line 63. So we messed up our indent. Wait, what? Did I only indent down to... That's weird. Okay. Yeah, so we get way more stuff than we are supposed to get. We can add some here, just left, right, up. That is up, right? Yeah. Down. This is up, left. This is upright. This is down, right. And this is down, left. Not left, left. Okay, let us see. Right. So it doesn't see anything to the left. That makes sense because we're at 0, 0. Yeah, there's a lot of neighbors. Oh, hi there, Lino. So to the right, it sees this. Oh, right, we don't break. That's our bug. So we should yield that and break. There we go. It sees this, it sees this, it sees this. That looks good. So basically we didn't obey the rule of visible occupied seats. So yeah, this one would see all of these seats. because we didn't break. To be quite honest, I half expected yield to break for us, which is dumb because that's not what it should do. But that's what I was thinking when I wrote that, which was of course wrong. That. So now, unless this indentation was an error of something else. Ah, right. I removed the echo statement, but not the check there. So this should now give us. Oh, we need to. We need to not do the loop count thing. We can just print them out. It doesn't matter. 25. It should be 26. So, and shift as follows. So it has 1, 2, 3, 4, 5, 6, 7 iterations. We have 1, 2, 3, or wait. Yeah, he starts with the empty one. Oh, but ours doesn't. Oh, wait. Never mind. I filled this seat while we were testing. There we go. 26. That's what we expect. I'll fill up first and then carry on down to 26. Okay, now we can try and run this on our actual input. I kind of want to see. Yeah, we can fit a full line on, right? And I'm just going to remove this import. It's bugging me. Because we're not using stir-utils. So yeah, it's now just going to output all of our nice. So this is our seating pattern. I would try not being dumb. No. It's a struggle. I mean, I try not to be, but you know. Hey, that's the right answer. 1 gold star closer. Oh, so now it seems like we're getting right. So we flew there, and here we're getting on a ferry, and now we're going down here. This looks like a bigger island, though. Like, did this island have an airport, but not this one? What kind of nonsense is that? We should have just flown there. I mean, we had time to, like, hack the in-flight infotainment system on this flight. It must have been, like, I don't know. Well, I guess we spent, like, half an hour doing that, but, you know. Rest of string. Oh, that wasn't related. Yeah. So yeah, the thing Bindar shared earlier. I'm actually gonna pull that up. I thought it was cool. Let's see. So basically, he animated that output here. So this is what his seating arrangement looks like. This is for part 1, actually. You can see it's sort of like they tick back and forth between occupied and not occupied until it ends and start over. I thought that was pretty cool. Seizure warning, I guess. Hopefully no one is dying on their floor at the moment. Yeah. Did he post one for part 2? Solution is up. But the GIFs look broken in the README. Well, this looks fine. Yeah, so this is his part 2. So it's basically just slower at going in. and not. So this sort of creates islands and stuff. Well, this is more of a just going in from the sides. Does he have the code here to generate the... Oh wow, he's doing a lot. What? He's doing a lot of logic. What is he doing here? Use a ggplot. I was just thinking, like, if we could adapt this to... If we could adapt this to... it's a bit trippy. It's not trippy. Come on. Why are you so tired? You're a student. Oh no, wait. I guess you're not a student anymore. Yeah, you're doing work stuff. Welcome to the club of being tired from work. I'm not sure why I thought you were a student. Did you watch the SpaceX stream? Or were you up for something else? Oh no, wait, that was yesterday. That was the day before. Never mind. Yeah, I mean, you would need to create this grid object thing if we just want to copy paste this thing. Oh, just the data as a string with rows and columns. I guess we could. Could generate this. What is this good for? Constructs a file name, so it creates a bunch of PNGs. Yeah. No, it actually runs the whole thing in here. Well, what we could actually do, if we just want to like test it with our data set. I mean, his algorithm is doing the exact same thing as we are. So let's save this in my projects folder, which I'm not going to show you the complete contents of. Wait, where are mine? Oh, they're probably not counted as plain text. Yeah. We are going to store this as plotter. And we are gonna have a look at the code. As input, that's in his run test. He has a run day 11. Okay, so I guess we should be able to just do plotter. I know he uses, like, he calls convert. Cannot open file secmath. Is that something he has here? Oops. No. Is that a nimble? Secmath? Right. Have a good nap. Secmath. NIM sequence math library for sequences and nested sequences. Okay. It's not a whiz-bang linear algebra vector matrix statistical financial library. Yeah. I'm gonna install this. Then we'll install secmath. Undeclared identifier fmod. Wait. I'm on the latest NIM. Is there a new version of Sec? Wait, it should have installed the latest version of SecMath. Well, I'm not gonna debug that. So yeah, anyways, that was today's advent calendar being solved. A bit easier today, or maybe not easier, but certainly easier for me. I'm more of a computer science person and not so much like the math stuff. Oh, I pushed day 4, which I had lying around at work. I didn't want to merge. Wait. I don't want that merge commit. Yeah, I want my tree to look like that. That's fine. Yeah. Git push to origin master force. There we go. Oh, no. Oh, damn it. Go check out master. This has this. So you want to do a, what is it, a git rebase? Let's do an interactive rebase to like unstage changes. Oh. There. Oh no, that's not what we want either. Wait, what? Okay, yeah, sure. I mean, that's what we wanted. I don't care which order they're in. As long as I don't have copies. No, as long as I don't have those stupid merge commits. There we go. Yep. There we go. Quick and easy. Using a nice simple iterator and some nice templating to avoid having to repeat this for all of these. There's probably an easier way of doing this where you like go, like we could, while going diagonals, we could also check this, but then we would have to make sure that we go all the way or something, but that's complicated. This is easy and it works. Okay, so again, that was day 11. Thanks for watching. Thanks for catching my little bug there. Whoever that was. That was Pietro Ropeter, or however he says his name. Yeah. Anyways, have a good weekend. It's Friday today. I'm still just drinking water, which is a shame. So yeah, have a good weekend. Have fun. I'm not entirely sure if I will be able to stream during this weekend. Hopefully, because I think this is kind of fun. is a nice little challenge to program with an audience and not knowing what the actual challenge is. Uh, like with when I'm streaming Notification and stuff, I have sort of looked at the problem before I sort of know what I'm gonna do. With these, there's sort of something new every day. It's kind of fun. So yeah. Anyways, have a nice weekend. Have fun, and have a nice rest of Advent.